Most of us take for granted that we can instantly recognize people we know by looking at their faces. It's so automatic, it almost sounds silly to even say it. Friends can put on a hat, cut their hair, and still we know them by their face. We can do this for thousands upon thousands of faces without ever giving it a moment's thought. But imagine for a second what life would be like if you couldn't. If your wife or husband looked like a stranger. You couldn't tell your kids apart. Couldn't recognize yourself in a mirror. Well, that's what life is like for people who suffer from a mysterious condition called face blindness or prosopagnosia that can make it nearly impossible to recognize or identify faces. If you've never heard of face blindness, you're not alone. Chances are your doctor hasn't either. It's been unknown to most of the medical world until very recently. Hearing about it can feel a little like entering the twilight zone, but for people who are face blind, the condition is very real.
Here we take a closer look at patient LR, a man diagnosed with severe prosopagnosia. Patient LR got into a severe accident at the age of 19 where he received a penetrating head wound that would change his life forever. Young LR never expected that a ride in his buddy's truck would end in a life-changing neural impairment. One night, LR was riding in the passenger seat of his friend's truck when they suddenly ran into the car in front of them. LR was thrown from the front seat onto the truck's gear shift. But the plastic covering that usually protects the gear shift's sharp metal tube was missing, so when LR's head hit the lever, there wasn't anything between his skull and the metal tube to ease the blow. The hollow metal tube of the gear lever impaled LR's lower left cheek in the front of his jaw. The tube then passed through the bone, going through his left intracranial cavity and sphenoid sinus. It then entered his right cavernous sinus, clipped his right internal carotid artery, which injured his abducens nerve and maxillary division of his trigmenal nerve. It then pierced his right temporal lobe and left a bone fragment in the superficial aspect of his middle temporal gyrus. Shortly after his car accident, LR developed right temporal intracerebral hematoma, which was relieved in emergency surgery by clipping his right internal carotid artery. This emergency surgery unfortunately made him unable to get an MRI, which would later affect how researchers approached his case study. CT scans of LR's brain showed ablation of his anterior and inferior right temporal lobe, as well as injury to parts of his amygdala. His posterior regions, including his fusiform gyrus, were spared. The fusiform face area, FFA, is located within his injury and is located in the inferior temporal cortex of the brain, whose cells function to recognize faces.
In order to further understand prosopagnosia, it is important to explain the location of the neurological insult that patient LR suffered in his traumatic car incident. This insult includes the right temporal lobe, specifically the fusiform gyrus and the fusiform face area. There are many functions of the temporal lobe, such as auditory and visual processing, as well as language recognition. Damage to the temporal lobe can result in impairments in visual processing, as seen in patient LR. The large tan portion of this image highlights the location of the temporal lobe in the brain. The fusiform gyrus is a portion of the temporal lobe whose functions include the processing of color information, face and body recognition, word recognition, and within-category identification. Damage to the fusiform gyrus inhibits face and body recognition and within-category identification, indicating symptoms of prosopagnosia. This image shown is an fMRI scan of someone's fusiform face area, an area in the brain that allows us to recognize and remember faces located within the fusiform gyrus in the temporal lobe. As seen in this image, this specific area of the brain lights up when looking at images of people's faces during an MRI. However, when there is damage to that area, it will no longer show the same light patterns.
A view inspired by Gestalt psychology proposes that face stimulus can be initially represented at a global level. This view is supported by the fact that we categorize stimuli as faces even if it does not contain clear facial parts. For example, look at this image. Do you see a face in any of these? This image contains both Mooney faces and Argak and Boldo stimuli, which are said to require holistic processing for successful perception. This higher-order processing is made possible through the fusiform face area. In this picture, you can see the results from a study showing the increase in activity in the fusiform face area when the Mooney image and Iraq and bull's eye stimuli are presented upwards compared to when they are presented in reverse. There is no such effect in the right occipital face area. If a patient suffers damage to this area, the patient may be able to categorize the stimulus as a face, but cannot discriminate individual faces. In this image, you can see the difference between a patient suffering from prosopagnosia and a control. The top fMRI scans show damage to the fusiform face area. Below, you can see a brain without the damage. The middle graph shows reaction to different stimuli of faces, cars, and scrambled versions of the two. You can see how the fusiform face area reacts when presented with an upright picture of a face with this red line.
Our group believes that the Cambridge Face Memory Test would be the best test to use in preliminary examinations of patient LR. This test assesses an individual's ability to recognize faces, and in particular, it assesses the individual's ability to process a face holistically, which means glue the facial features together, as well as concept configural processing, which means processing second-order relations such as the spacing among features. The CFMT was created to test patients with deficits in facial recognition. It is currently the main standardized test used for face recognition ability and is commonly used in research. It has high internal consistent reliability, and it also reduces the patient's ability to use feature-based strategies to recognize faces, such as hair or clothing. What it looks like. Patients are exposed to 6 target faces and are given time to memorize each one. They then have to recognize the target faces amongst other distractor faces in a 3-alternative forced choice task. The test consists of multiple steps, and with each new step, the difficulty of the test is increased by changing the faces' positioning, lighting, and adding noise to them. At each stage, the test participants are asked if they recognize any of the target faces they have been exposed to earlier, and they press relevant keys on a keyboard that indicate either yes or no. We decided to test the CFMT on a new patient, patient MH. She claims she is unable to recognize her parents, and we believe that she is suffering from prosopagnolsia. In this clip, I sit down with the patient as she talks to me about all of her symptoms. During the first part of the test, she is given time to memorize the target faces. Next, she is shown 3 faces, one of them a target face, the others are distractor faces. Her thumbs down indicates she recognizes none of the faces, including the targets. The next level of the test gets harder. The faces are angled differently and the lighting has changed. MH is still unable to recognize the target faces. The final level is the most challenging. Noise has been added to the faces, giving them a pixelated look. MH is unable to process the faces holistically, or process the space between facial features, which are both processes needed in recognizing familiar faces. Based on this test, it would appear she is suffering from prosopagnosia.
Although patient LR never took the CFMT test, we hypothesized that he would have still been diagnosed with prosopagnosia. CT scans revealed ablation of the anterior and inferior right temporal lobe affecting the amygdala. Although patient LR maintained 20/20 vision, normal range of working memory and general memory, and has an intelligence level above average, the neurological damage has forced him into a frustrating and irreversible position, lacking the ability to recognize the faces around him. The use of this test on patient LR, who has a severe case of prosopagnosia, should reveal that he cannot recognize the familiar faces presented in the assessment due to the insults in the temporal lobe. Furthermore, the use of the CFMT in collaboration with other reliable neurological assessments for prosopagnosia will strengthen our understanding of patient LR's complex neurological deficit.
Now we're going to test your ability to recognize faces. Recognize this guy?